Hello, welcome to Introduction to Java Programming. In this session, we will discuss packages in Java. Let's begin. So, what is a package? So, package is a keyword in Java, and a package is a grouping thing. It groups what? A package is a grouping of related types. So, it groups classes, it groups interfaces, and it groups exceptions, which are also classes, which groups annotations, okay, which are some interfaces. So usually a package is a grouping of some related types. So there's those may be classes and classes plus interface and etc etc. Okay, and here we have so many packages which are defined in the Java API. So we will see java.lang package, right? So lang is the base package. All the fundamental classes are available in the lang package, and by default that is imported to your Java program. And we have util package where scanner or date kind of things we are using, right? So before actually going to see the advantage of package, let's understand few more details here. So a package is a keyword. So by having package, we can create our own packages also. And we have another keyword called import. By using this import keyword, we can actually import other packages to our program or application. Two things. One, first thing is already there are so many packages available as part of the Java API. You can import them straight away and use them in your program. Second thing is you create your own packages and use them in other applications. So otherwise, I can say you can group what are all the classes that you are writing or interfaces into some packages, and you can import them into your programs. Usually, these two things will happen actually. So initially, we will understand the definition of a package. What is a package? It's a grouping thing. It's a groups related types. It groups logical types. For example, I'm actually assume doing a project on a student management system, right? So now I have to write so many classes which are related to student in a university. So student class is required, teacher class is required, courses class is required, and etc etc. Now what I do is all student related things I can keep in a student package. All teacher related things I can keep in teacher package. All courses related thing I can keep in courses package. Related things means all class and interfaces. And if any exceptions I create, those exceptions also. So that what happens, we will have the uh, we will have the logical grouping, of course, because we are clearly categorizing the things into different divisions, and it helps us in easy maintenance. We can maintain the things so easily. For example, I want to change something which is related to student. I will go to student package and I can do that. If something I need related to the courses, I can straight away go to the course package and I can do that. So, first benefit that you can see is the logical grouping. By the definition, it actually fosters easy maintenance. The second thing is actually by having packages, we can have access protection, extra access protection, right? So access protection is already there at the class level. In a class, we have data members. We will make them private and we access them through methods. That's called encapsulation, right? And you are taking this class and putting into some other entity that is actually a package, right? So if at all somebody want to access, first they have to come to the package and then to the class, right? So that's why we say packages will provide enhanced access protection. And most important is actually the third benefit, that is the naming collision resolution. So now all applications that we develop are very big in nature. Okay, if at all you are actually maintaining some enterprise application. So enterprise application is an application that is spread across the world. It's a distributed application. So you will be doing from your place and somebody else also working on the same project from from other place. At the same time, n number of people will be working. right? So what is the naming collision thing actually? So for example, I have created a class called A, let us assume, okay, and here the same class has been used by some other colleague actually who is working in the same project. Okay, so now what happens when we integrate? When we integrate, I will have a duplicate ambiguity. So I did something and somebody did something, and we are integrating the whole thing, and we actually have a collision, right? So they are also using A, I am also using A. So this is ambiguity and our code doesn't work. Rather, what I can do is I can put this particular class in my package, and this class can be put into her package or his package, whoever it is actually, right? So now let's say I have a package called HYD package. So my class actually is HYD.a, and let's say somebody is from Pune, so then it should be Pune.a, right? So now same class names, but packages are different actually. So that's how we can solve the naming issues actually, naming conflicts. So it's a most common thing. Naming conflict is a most common thing. We can actually solve this with the help of packages. So these are the benefits. And Java has so big API. So Java API is so big. You can see so many packages, right? So let's understand the packages, and then we will actually see how to import a package from other package. Okay, so this is what the definition we have seen, and this will be a package will be having interfaces, classes, exceptions, annotations, etc. and etc. And this advantage we have covered actually. So package is to categorize the class and interfaces so that they can be easily maintained. Package provides access protection, extra layer of access protection. Already access protection was there through encapsulation, and packages remove naming collision. They solve naming issues actually. And if you see the Java API, you will have different packages. So lang package is there. So all fundamental classes which are required for a programmer to write and run a program are available in lang package, and all utility classes in util package. We have AWT, abstract window toolkit. Now, of course, it is deprecated. So we have swing package, we have net package, we have IO package. Okay, we have SQL package. Like that, there are good number of packages, and all those packages will contain what? Classes and interfaces. Okay, of course, exceptions are also classes, annotations are also or interfaces. So broadly, we can say packages will contain classes and interfaces. In fact, a package can contain sub-package also. So for example, if you see at the top level, we have a package called Java, and we have a sub-package called lang. So java.lang, that is how we access the sub-packages, java.lang. In the lang, I have actually so many classes, right? So lang has system class, lang has string class. We know in first Java program, we write string array args and system.out.println. So those are the two basic classes that we have to write in every Java program. Okay, so now how do I access this system? Java.lang.system, java.lang.string. So that is a fully qualified name, the full name actually. Now, if you see, these packages are containing all the .class files. That means a package contains all precompiled Java classes. Precompiled Java classes. A package is going to have .class files. Straight away, I can use them. Okay, I will import this package and straight away I can use it. Okay, so from here you need to understand. So for core part of Java, the super package is Java, and it has so many sub packages, lang, util, AWT, and of course lang has sub packages like reflect, etc. So you can have as many sub packages as possible. Okay, so a package contains sub packages, and along with the sub packages, they can have classes and interfaces. Okay, so before I go to access how to access package from other package, let me actually show you also. So one thing actually. So this is Java API documentation. So here, if you see, you know how to see Java Java API documentation, right? So you have to go to oracle.com/Java, and then you go to API documentation, then click, then you will come back here. And here you can actually see java.io, java.lang, all these things are there, right? So now I'm interested in lang package, let us assume. So in the lang package, we have string class, system class, etc. So you can all see them, and so many classes, not one, so many classes. So let me actually show you a string class, and there is a system class, string buffer, string builder, all string related classes, so many classes. So what it is actually having? So it having classes, interfaces. Okay, of course, enum is also just like a class. Exception is also a class, and annotations are interfaces. All are grouped into a single thing that is actually package. So like that, we can actually see so many other packages. For example, you go to java.util and you can find good utility classes. For example, here I can actually have some class which is very useful, that is called a date class, and I have some other class called calendar class. Okay, I have a scanner class to read something. So now I want to understand this date class actually. So this date class is defined here. See, class date, which is defined in package java.util, and so how it is written? See, this class date, public class date extends object. Object is a superclass of all classes, row. So date is extending object class, and a date class is implementing many interfaces. So we know date class implement multiple inheritance kind of thing is possible with interfaces. So it implements serializable, clonable, and comparable. Date class extends object, implements serializable. That means data object can be serialized, data object can be cloned. That serializable and clonable are marker interfaces. We know that, and comparable is also there. So you can compare one date with other date. So this is how the class is written, and of course we have so many constructors here. Default constructor, that parameters, etc. And there are so many other methods like get date, get day, get hours. Okay, set month, set year. So many toString. Okay, so now yeah, so this is the API. API is so big, you have so many packages defined inside. Now, how to access a package from the other package? So how we are going to access a package from other package? So we have three ways actually. So you can import whole of the package by specifying the star, and you can import a specific class or interfaces from a package, and you can import a class directly by using the fully qualified name. So you don't require to use import keyword over here. Okay, so for example, I have util package, so I can say import java.util.star. So everything of util package is available to my program. Then I can say package import java.util.date. Then only date class is available to me. So now the other means is I can straight away use the fully qualified name. I know date class is there in util package, and its full name is java.util.date. So when I use full name, I need not to import it actually. So when you import, what happens? When you import with the star, all the classes and interface of that package are directly available except the sub packages. So in a package, you have class and interfaces, they're available to you. And a package can have sub package also, but the contents of the sub package are not available to us. If you want sub package contents, you have to go to that sub package and you have to ask for that. Okay, so let me actually tell you with an example all these things. Yeah, so what I'm saying is we can import a package from other package in three ways. One is implicit import. What is implicit import? So implicit import means you are not telling clearly which class you are importing or which package you are importing. So import java.util.star. Okay, this is called implicit import. So automatically everything will get imported. So we are not very much clear about what class is required or what interface is required to me, right? Everything. Star means all. Star means all. But when you say all classes and interfaces, okay, not sub packages, but not sub packages. Okay. So then coming to the explicit import, in the explicit import, what happens? You know, we are clearly telling what we want. So now I am going to tell here. So import I am saying import is the keyword. I am saying I want from Java package, and there is a package called util package, and from the util package I want date class. So only date class is available to you. Only the date class is available to you. Okay, that is called explicit import. And then we can directly use any class in the API with a fully qualified name. So for example, I want to use date class. I can say straight away like this: java.util.date, and it refers to the API, and it refers to that particular package, and date class is available to me. So these are the three ways by which we can actually import a package from other package. Fine. So implicit import, explicit import, and using the fully qualified name. So now let me write a program actually. So the program is to print today's date. I want to print today's date actually. So how to do that actually? So program to print today's date. So how to print today's date actually? So today's timestamp we want to print. Okay, so just now we have seen there is a date class available in the util package. So I need to import that. So what I'm doing is import java.util.star. So firstly, I'm using implicit import. Just to tell you that there is implicit import. Even though I require only date class, I'm doing implicit import. So now what happens? Uh, all the classes, including scanner, date, all my collection classes and interface, everything are available because I'm saying implicit import over here. So now what happens? Import java.util.star. Now I can use that class date class, and I can create some object from it. Date d equal to new date. Okay, so date d equal to new date. So what happens here? Date object is getting created. So date object has got created here. So now in order to print today's date, what I use is straight away, I will actually print it D. I will actually print D. So you know what happens when I print D, toString method will come into picture, right? So now D is not object reference that is going to get printed. So what is going to happen is the toString method is overridden in date class. So in Java API, when the date class is written, they have written the toString method also there. They have overridden the object class toString method. So that's why when I print D, I will get uh, I will I will be getting the date, okay, not the object reference. So now this is test.java. Let me go to my terminal, and let me go to this folder where it's actually getting saved. Let me save this into practice.java. So yeah, so I'm saving here, and it's already there, so I'm replacing it. Okay, fine. So I need to go to my current folder actually. So that is practice Java. So let's say cd. Yeah. So this is the folder, and when you say ls, now you have so many classes, and we have test.java classes also available. Now let me compile this. So I say java c test.java. It's compiled successfully, and when I say java test, java space test, now you can actually see the date getting printed. So this is Wednesday, and it's May 24th, and the time is 7:14 IST 2023, right? So this is how you can print date using the predefined date class, Okay, so now this is implicit import, right? Now what I'm going to do is I'm going to say date. So now what happens to this now? This is going to be explicit import. This is called explicit import because I'm explicitly saying what I want. Only date class is available to me now. Scanner, all other collection class interface are not available to me. Only the date class is available to me because this is an explicit import. Okay, so since I have explicitly imported it, I can use it. Date d equal to new date, and system.out.println d. So you want to write any string here, you can actually say today's current timestamp. So because it is giving me complete timestamp, right? So it is telling me what is the day, it is telling me what is the day, what is the time, what is the IST, everything, right? So this we call as a timestamp actually. So just to print the current timestamp, so I have written the code and I need to compile this and let me run. So Java C test.java, and when I run Java space test, then you can actually see the today's current timestamp is Wednesday and this is 7:16. Okay, so again you run. Now it will actually change to 7:60 35 seconds. Again you run, it's actually 7:16 40 seconds, like that. So it picks actually the system time. Okay, so how it works means it picks the system time, right? So this is how you can understand how we are actually importing uh, the predefined classes from the API, right? Explicit import, implicit import. So what is the other actually? The other thing, so for example, I am actually commenting this. So when I comment this, this package is not available. So now the package is not available. I'm trying to create a data object. Will it be available to me? So package is not there. I'm not importing it, right? It's there in date class and it's not available. And I have not written any date class in my folder, right? Because I don't want to write also, because already it is there in the package and I can use it straight away, right? So now let's see if when I compile, what is going to happen. So because I'm not importing it, but I have to, I'm using date class. Now let's see. So it says cannot find symbol. Okay, compiler says you are saying date d equal to new date, but I didn't find any date dot class in your current folder. Okay, that is practice Java. I didn't see any class called date. Either you are not importing from any of the packages. So it gives me an error actually, right? So that's why you need to import it, either explicit import or implicit import. And you don't want to import. There is another way. That is actually fully qualified name, right? FQN. Okay, you have implicit, you have explicit, and fully qualified name can be used. So whenever I say Java, what I do is Java dot util dot date. And here also I'm using date class, right? Again, there also I have to say Java dot util dot date. Okay, and today's current timestamp is D. So this is using fully qualified name. This is by using fully qualified name. So I'm not importing, but I'm using its full name, Java dot util dot date D equal to new Java dot util dot date. Fine. So I can use that actually. So now your program will work and you are going to see the outcome. So let me compile this. Compiled successfully. And when I run, now you can actually see today's current stamp is 7:19 actually. So morning 7:19 20 seconds IST 2020. Right. So this is how you can actually import. So there are three ways to import a package from other package. So you have implicit import, you have explicit import, and you can actually do by fully qualified name. So just as an example, I have shown you about the date. And now what I can do is I can say import java.util here scanner. You know how to use scanner already, right? Okay, so what I'm doing, scanner I'm straight away using, and date I'm using fully qualified name. Okay, so after printing all these things, what I'm doing is I'm creating a scanner object. So scan is available, so that is explicit import. So scanner some in equal to or in or input, whatever the name actually. So new scanner, this is how we create a scanner object, and we are going to read from uh, input console. So system.in actually. So scanner in equal to new scanner of system.in, and then you can ask for something. So enter your good name. Enter your good name. So a string is going to get entered. So I require something, a string variable to hold that, whatever I'm reading. So string name equal to, so in dot. So how to read, you want to read a string token next. You want to read a full line, next line. For example, if your name has, your name is not a one single word, it's multiple, then you can use the next line. right? So then we can actually print. So your because we are reading the name, so we are saying hello, Mr. or Miss, whatever it is. Hello, Mr. or Miss, so and so. So the name is entered, right? So we are actually printing that. So just to tell you that I am using another class, that is scanner over here. So it's also part of the util package. Not just one util package. We have so many packages: IO package, net package, SQL package. So different. SQL means all database related. Net means all networking related. IO package means all input output related. Util means all utility related. So like that we have so many packages. Java API is so big, right? So let me now compile this and show you that, and date is also going to get printed, and at the same time scanner also will work, and it asks me to enter a name. Yeah, so today's current timestamp has got printed, and enter your good name. Now I am saying my name is Java, and it says hello Mr. or Miss Java, right? So this is just a simple example to make you to understand about the packages. Okay, so I think the basic things are clear. What is the package, what are the benefits, and how to import a package, and what is explicit import and what is implicit import. And without using import keyword, still you can access the class and interface of the packages, that is using fully qualified name. So in the next session we are going to see how to create our own packages, not using the API packages, how to create our own packages, creating custom packages, and how to import them into our package. So that is interesting, and for that you require a special um, flags to be used while you are compiling and running. So that we will see in the next session. Thank you.